Okay, here's another question I found on Reddit. Another question from Slay the PE. So the question states, saturated steam at 5 psig enters a heating coil and is discharged as saturated liquid. The heating coil is used to raise the temperature of 450 CFM of air by 30 degrees Fahrenheit. The flow rate in gallons per hour of hot condensate is most nearly what? Okay, so I'm going to draw a little diagram. So we have our heating coil. Let's say we have some air going through some ductwork. So we have 450 CFM of air coming in at some temperature 1 and leaving at some temperature 2. Now we don't know what those temperatures are, but we do know that the delta between the two is this 30 degrees Fahrenheit. So T2 minus T1 equals 30. And we know we have steam coming into this heating coil. So steam enters at 5 psi gauge. So we really need to get this psi gauge into psi absolute. So pressure absolute equals pressure gauge plus pressure atmospheric. So this pressure gauge is 5, and we know that pressure atmospheric is 14.7 psi. So 14.7 plus 5 is 19.7 absolute. We know that it enters at saturated steam. So this is a saturated vapor. And it leaves as a saturated liquid. So saturated liquid. So if we look at it, say on the pH diagram, a little vapor barrier or vapor curve, we know that the steam is starting as a saturated vapor here and then leaving as a saturated liquid. So this would be H liquid, and this would be, I guess it would be HF for fluid, and then this would be Hg for gas. So as the air passes over this heating coil, it's taking energy from that steam and bringing it down to this vapor state or liquid state. So we really need to find this delta H. So if we go to our steam tables, we're given the pressure. It was 19.7, so we'll just use this 20 here. And we're looking for that HFG, so that enthalpy from gas to fluid, delta between the two, which is 959 or 960. So HFG equals 960 BTUH. Or the units, BTU per pound mass. Sorry. Okay, so we need an equation that will equate the heat transfer from the air to the steam. So we can use our sensible heat equation for the air. So Q sensible equals 1.085 CFM delta T of air. So we know what our delta T of air is. That's 30, this guy here. And we know what our CFM is. That's this 450. So we can get the heat transferred to the air. So let me get my calculator. So this is 14,648 BTUH. So 14,648 BTUH. And this is how much heat or energy the steam is giving up. So for our steam, we're going to have some mass flow rate times delta H equals this QS. So equals 14,648 BTUH. So we know what this delta H is. That's this guy here. The enthalpy from gas to fluid. So we're going to divide that here. So we're going to get 960 BTU per pound mass. So we end up getting a m dot of, let me do the math real quick. So 14,648 divided by 960. So we get 15.3. So this mass comes up here, and then we have this H that's down here. So we get pound mass per hour. So 15.3 pounds per hour of condensate. But the question is asking for gallons per hour. So if we go to our PE handbook, we can go to engineering practice and then keep going down to commonly used equivalents. So we know that 1 gallon of water is equal to 8.34 pound mass. So let me grab that guy. So just do a unit conversion here. 8.34 pound mass per gallon. These pound masses will cancel. So 15.3 divided by 8.34. That is 1.8. So 1.8 gallons per hour. Now if we go up here, closest would be 2, and that will be our answer.